This is number 4 on the AP review. Particle motion. This is a calculator problem. Let's read the problem. A particle moves along a straight line. For t value between 0 and 5, the velocity is given by -2 plus t squared plus 3t to the 6/5 minus t cubed. Position of the particle is given by s of t. We're told that our position at time t equals 0 is 10. Find all the values in which the speed of the particle is 2. Now, here's something that we got to be careful about. It's not saying when the velocity is 2, because if it's just velocity equal to 2, we can just put 2 in for velocity and then plug in the calculator and try to find that place where velocity is 2. But here it's saying where the speed is 2. So speed is the absolute value of velocity, is related to velocity, but we have to take into account that it's testing to see if students recognize that this is really saying find when this particle is going to reach a velocity of 2 and -2. So what we're going to do is we're going to graph our velocity function, and then we're going to graph our velocity 2 and -2 and see where they intersect. So in our calculator, we can plug in this velocity function, and velocity function will look something like this. We also have y equals 2 and y equals -2 all in place, and then in our calculator we can use the feature of second trace intersect to find the intersection between these two graphs, and that intersection is going to be at time t equals 3.128, and then separately we'll use the second trace intersect feature to find this other intersection, which is at 3.4. So 3.2 and 3.4 is when this particle is going to reach a velocity of 2 and -2 in the time interval from 2 to 4. So there's another place where velocity is 2, but it's outside the interval, so we only choose what's between our two intervals. Part B, write an expression that gives the position function. So position function, we know final position equals initial plus displacement. So we can say s of 5 is equal to s of 0 plus the definite interval from 0 to 5 of v of t. We can enter this in our calculator. So we get 10 minus 19.207. Combine those to be -9.207. Part C, find all the time t in the interval from 0 to 5 where the particle changes direction. Particle changes direction where the velocity changed from positive to negative or from negative to positive. So we're going to find our critical points first. We're going to take our velocity function and see where it changes direction. So we can graph our velocity function. You can use, after you graph it, you can use second trace 0 to find the two x-intercepts. So the two x-intercepts will be at 0.536 and at 3.3178. We place those critical points onto our velocity sign line. We can test values, or we can look at the graph. We can tell that between 0 and 0.5 we have negative velocity. Between 0.5 and 3.37 it's a positive velocity, and between 3.3 and 5 is negative velocity. Okay. So particle changes direction at 0.5 and 0.3 because we see change in signs. So not only is velocity 0, but our velocity sign actually changes from positive to negative or from negative to positive. Okay, part D, is the speed of the particle increasing or decreasing? Speed of the particle increase, decrease. This is dependent on comparing signs between velocity and acceleration. So we have our velocity function. We can plug 4 into the velocity function, and we're going to get -11.47. And we can also use our end derivative feature to find the acceleration at t equals 4. And that is going to result in a negative value as well. So velocity and acceleration are both negative. They have the same signs, which indicates that speed of the particle is going to be increasing at that time t equals 4.